So welcome everyone for the research seminar series today. Today we have with us Professor Ram Fishman from the Tel Aviv University. He's an assistant professor in the public policy area. Prior to Tel Aviv University, he was working with the George Washington University in the econ area. And prior to that, he was a postdoctoral fellow at the Kennedy School of Government, Howard Kennedy School of Government. In the same program where I think I also spent about 2 years.
Okay.
So I think that's how we got connected. But however, this is the first time we are meeting here in India. So he's doing some very exciting field work in India in the area of agriculture and efficient use of resources for agriculture in India. So welcome Ram and over to you. Thank you.
So thank you very much for the invitation. I've broadened a little bit the question, the title from, I will be talking about drip irrigation, but I think I'd like to contextualize it in the broader question of the sustainability of Indian agriculture, especially from the point of view of water. I guess most of you are aware that there's a water issue for Indian agriculture, but more broadly, in general, if we kind of zoom out a little bit for a minute, there's a need for agriculture all over the world to become much more efficient and precise in its use of resources because of the tension between the need to increase food production and increase farmers' income on the one hand, and the need to reduce the environmental footprint of agriculture all over the world. I think one of the key points is that technologies that can do that already exist. There's no real need to invent new technologies to do that. For example, in the case of water, I'll be focusing on a particular irrigation technology that can basically not only maintain yields, but even increase yields, while at the same time reducing the water requirements by half in some cases, depending on the crop. So given that technologies like that exist, the nature of the problem is really not so much technological, but more related to the human side, the farmer's side. Why are these technologies not spreading? These are win-win technologies that help incomes and the environment. And so understanding what and why, whether or not they are spreading, and if they're not, what prevents them from spreading, is very important. Now we know that technologies don't diffuse very easily normally. Any kind of technology, especially in agriculture, we know does not always diffuse very smoothly. So all the barriers that are preventing other technologies from spreading probably are also preventing green technologies from spreading. But in addition to that, there's another host of problems, which is that the incentives for adopting technologies that have like a public benefit are also not sufficient. So on top of all the regular problems and challenges facing in diffusion of a new technology in agriculture, especially by smallholder farmers, here there's another layer that part of the benefits of these technologies, which is using less water, is not something that most farmers may be as concerned about from their private point of view as the public is. Okay? So in the discussion about what will induce an adoption of these kind of technologies, one usually comes across three types of sort of narratives. One point of view is that there's no real need for external intervention. Scarcity itself is going to trigger an adoption of more efficient technologies. Once farmers really feel scarcity, then automatically they will develop or adopt technologies that will enable them to manage with less water. That's one point of view, one narrative. However, before I go there, okay, so this is one narrative. A second narrative is that economists usually like is that it's all about incentives. And if the incentives are misaligned, technologies are not adopted. Specifically, water is often not priced. And when there is no price, people don't try to economize and use it efficiently. That's another point of view. And that means that the policy prescription to deal with the problem is to set the prices correctly. A third a third approach is more centered about pushing those technologies proactively rather than indirectly through incentives or through or wait for scarcity to impact, a more proactive policy engagement to support the diffusion of these technologies. That could happen through subsidies, through awareness, information, education, and extension, or in many other ways, and there is a debate around the merit of these kind of approaches. So generally, economists feel that subsidies have distortive effects, and the most efficient way, most efficient policy is to just price things correctly. However, I think given a lot of frictions, especially with smallholders in emerging markets, it's not obvious that this will be true as a panacea. Another big question is whether the approach that is centered on pushing new technologies without setting the prices correctly, whether pushing technologies which are efficient will actually lead to using less water. And that's not obvious at all, and in fact, we'll see that it may not be true. Yeah, so I discussed this. Now the point is here that regarding the first two narratives, basically me and collaborators, we've been engaged in a series of field studies here in Gujarat, which tries to gain some empirical evidence by which we can discern between those various narratives. So the first scenario, the first narrative is that scarcity itself will drive more efficient use of water. However, in the previous study we did here, we utilized a natural experiment in which different villages, because of different characteristics of their hydrogeology, 500 feet below the surface, they have a sort of different trends at which the water table is falling. So it's like a natural experiment that differentiates two different types of villages. In one type, I'm not going to go into too much detail, but it allows us to really estimate the impacts of greater scarcity on the responses of farmers. And that study showed that actually in villages that are more strongly affected by greater scarcity, we don't see a real transition to more efficient agriculture. So agriculture is shrinking. There is very little adoption of more efficient ways of using water. Instead, what most farmers are doing in those villages is to increase the migration rates of their sons to cities to work outside of agriculture. So that's a small study in a small part of Gujarat. It may not be representative in general, but it does suggest that maybe just scarcity by itself is not what is going to drive people to shift their agriculture, their irrigation, to be more efficient and sustainable. Another study we did on incentives was centered on this issue of pricing, the fact that groundwater is not priced in India, and even the electricity that farmers use to pump is only billed on a flat rate, not on a volumetric per unit basis. So many people believe that that is the root cause of the inefficiency by which farmers are using groundwater. So we worked with the government of Gujarat and the North Gujarat Utility Company to do a sort of a field experiment where some farmers were offered incentives in the form of rebates, financial compensation, if they reduce their energy use below a baseline level per unit. That was something that was hard to implement. It's politically very sensitive, but it was implemented successfully, but did not show any impact on how much energy farmers actually use for pumping. So that, contrary to everybody's, including our own expectation, that policy instrument did not have an effect. It didn't seem that incentives create an effect. Again, I don't want to push that too much because it's one study in a small area. It is the first of its kind. I hope more studies like that are done in the future to really shed more light on the question, but it does raise a doubt about whether incentives by themselves will solve the problem. One of the big takeaways for me from that experience was farmers coming to our field office and saying, we love this policy, we would like to get these compensations, but we don't know how to save water. Okay, so that kind of brought home the point of maybe there's not enough information and awareness amongst farmers, or maybe the technologies that can save water are not really that accessible to them, either because of cost or because of information, which is the subject I'm going to focus on today. Okay, so this is just a very long introduction to where we're going. Okay, so now let's take it more to the context of India. I don't think I need to spend any more time here about the nature of the groundwater problem in India. I'm sure you are more familiar with it than I am. And really the paradox we want to address here is the fact that despite the fact that water tables are falling and water is becoming more scarce, almost all Indian farmers flood their field. Those farmers who irrigate their land just flood their field, which is a very inefficient way physically of using water. We have technologies, for example.
Less than 90%.
Sorry?
Micro irrigation area now is more than 10% of the total. This is dated.
This is outdated, yeah. Okay, so see, that's what I was afraid of exactly. Right, but I think that even 10% out of all the potential area, so that's not a lot, right? It is changing, and in Gujarat it's actually changing rapidly. But understanding who adopts and why is interesting, and I'm going to focus on a particular technology, drip irrigation, which is originally an Israeli technology, which basically delivers water to crops rather than flooding than through little holes, through a network of pipes in the field. And there are holes near the plants, and so drops are coming out of those little holes and just providing water directly to the root zone of the crops. So it's very efficient. You can save more than half of the water that way. And so these, sometimes it's called micro irrigation systems. And again, adoption is still quite low despite the great scarcity. So why? Why is that the case? There are a bunch of possible explanations. Why is it about high costs? This is not a cheap technology. It's quite expensive. The other is that, again, going back to the previous question, maybe it's because farmers do not have incentives to save water, since they do not have to pay for their water on a volumetric basis. And the other is just the usual suspects that we talk about any technology. People don't know it, they're not familiar, too risky for them, and so forth. Now, the government of India is doing a lot to try and diffuse this particular technology. The government of India sees it as a potential pillar of its attempts to solve the groundwater problem. Pricing groundwater, pricing the electricity for pumping is an obvious other policy tool, but it's politically very problematic, right? You all know the history of the politics of groundwater electricity for subsidies, agricultural electricity subsidies. So instead, the government is trying to just basically push this technology by subsidizing it quite generously. The central government is actually offering 50% subsidy on the purchases. And different states may add additional amount. Now, Gujarat is one of the leaders of India in terms of diffusion of the technology, and also in terms of, I think, the way the subsidy is actually managed and administered. So you know more about that than me. There's an agency, GGRC, which from my impression was very, very well managed and has a very transparent mechanism of disbursing the subsidies, which was also the source of the data we use here. And we are going to basically try to use that experience in this state to try to kind of gain some understanding of the factors driving adoption. So we are going to ask a couple of questions. First of all, to what extent is there learning in the use of this technology? To what extent are farmers learning from one another? To what extent do the subsidy actually increase uptake? One may wonder if subsidy has anything to do with the diffusion of the technology. Maybe this is all a huge waste of money. Maybe everybody who is adopting drip would have adopted it even without the subsidy, right? That would be interesting to know. And finally, the question we'll look at is whether once somebody adopts drip irrigation, does that person actually use less water? Just because the water requirements per acre are going down doesn't mean that the total amount of water that farmer will use is actually going to go down as well, right? And we can talk about that in a little more detail soon. So just a preview. I'm going to focus here on the question of the subsidy. To what extent does subsidy actually increase the uptake of the technology? I'll show you evidence. Hopefully will convince you that yes, substantially. Whenever the subsidy is higher, many more people adopt it. But unfortunately, it doesn't encourage the smallest farmers, smallholders, to take up drip. So within the more larger landowners, and I'm not talking about large, but let's say medium size, amongst those, the subsidy does have an effect. But it doesn't help the really small farmers to adopt. And secondly, regarding whether adoption actually leads to reductions in water use, here it will be a mixed picture. This is still work in progress, so I don't want to push it too much, but the preliminary results suggest that actually in the short term, adopting drip actually increases the amount of water people use. So I hope to maybe discuss it towards the end and get some insights from you on what might be happening. So starting in 2005, the Gujarat Green Revolution company started to operate the disbursement of the subsidy for drip in the state. Since 2005 until like a year and a half ago, almost 500,000 purchases of micro-irrigation took place through GGRC. And here, I don't know if you can see this, but that includes both sprinkler and drip. Sprinkler is just a similar technology. And you see here the number of adoptions taking place per year in drip, sprinkler, and mini sprinkler, which for the purpose of this analysis are all equivalent. They're all technologies that save water. All are micro-irrigation technologies. So you see how there's an increase in the number of purchases per year since then. Now, the main data we're going to use here is...
The area under sprinkler is higher in Gujarat. It's higher, right? Adoption of sprinkler is more than drip. Previous graph showed that.
It might be. It might be. Here I'm going to focus on drip in the analysis.
You focus on drip, not sprinkler, or both.
You know, it's a good question. I think because drip is actually the water saving potential is, I think, higher than in sprinkler. And I guess I'm just emotionally a little bit more attached to drip, to be honest. But everything we do here, I should and can replicate to the case of sprinkler as well. So it's rather arbitrary, actually. You're right. Everything that I'll show you, we can also analyze for sprinkler, and I'll do that.
So we have a lot of issues with this, whether to promote drip or sprinkler.
I see.
Farmers have preferences and likes and dislikes.
I see. So a farmer is free to choose, though, between the two?
Yeah, they can choose, yeah.
Okay.
Yeah.
It's not like funds are allocated?
No, state is just promoting any of these.
I see. Okay.
Yeah.
I see. So I guess the main difference is sprinklers are less expensive and also save less water. So maybe it's like a smaller step for a farmer. Yeah.
Yeah, also it's easy to replace it. Take it out from field and put it again.
Yeah. Although I think many farmers just roll back the pipes whenever they need to. Fair point. So the data we got very generously from GGRC. They have given us information about any event. Event meaning whenever a farmer somewhere decides to purchase drip through GGRC, we know when, where, in which village, we know what crop, we know the landholding size of the farmer, and a few other details. So we have basically put together all this data. We have merged it with census coordinates of the villages in Gujarat, and that enables us to draw maps of, in every particular time since 2005, whenever somebody adopts drip, we can put it on the map. And let me show you what that looks like. So here what you see is whenever somebody adopts drip in a particular month, a big green dot appears. And the small green dots are just the cumulative. So once a village has adopted drip, you see a small green dot there, and you see gradually with time, you see kind of how this thing spreads all over the state. And I can't help show this because it took so long to produce this thing. So I'm going to show it 3 or 4 times now, if you don't mind. No, I'm joking, just once. But you see that by 2014-15, more than half of the villages in the state already have at least one farmer that has drip. So it's spread quite substantially all over Gujarat. So the first question we can try to ask with this data is this question about whether subsidies actually increase adoption, or maybe they don't really have a large effect, and maybe it's all a waste of money. Just in terms of motivation, if you actually look at the Indian states and you compare how large is the subsidy in that particular state, there is variation across states in how much subsidy they offer. The center gives 50%, the state can top it up with additional amounts. So, and on the y-axis, you see how much of the area is actually installed with drip. Then you don't see any correlation, right? So you don't see any signal by which states that offer a bigger subsidy see more adoption. So that, it's just a silly correlation. I'm not trying to push it in any serious way, but it just raises the question of it casts doubt on whether subsidies have anything to do with the rate of adoption.
Did you happen to look at the kind of ownership of land and if it's any different in different states?
Yeah, no, because you're absolutely right. I cannot learn anything from this without, there's so many other things that are different between states. So this is not nothing we can learn anything, but I'm just in way of motivations showing there is no clear correlation when you look at the state level. And obviously that's a bad exercise. It's not, there are so many other things that are different between
But the amount of subsidies pumped in Gujarat, then what I can say about it, and the Gujarat being the example for the entire country, I think there is a correlation, right?
So exactly what we're going to do here is instead of looking across states, which is not very informative, we are going to utilize the Gujarat data only to try to answer this question. Okay, so this is only motivation. What we are going to do is exploit the following things. So everybody can get 50% all the time. That's uniform everywhere. Now, if there is no variation in the level of subsidy, then it's going to be hard to estimate the effects on adoption. But fortunately for us, there is variation for the following reason. It just so happens that occasionally, in a particular taluka, in a particular year, a particular drip company, of which there are many, by the way, will come together. Maybe a particular company with some local government or local NGO will come together and have like a special scheme, limited time scheme, where they will offer some additional amount of subsidy for drip. It may be 10%, it may be 20% on top of the 50%.
Well, that brings in variation, but that confounds the problem. Along with subsidy, you're also bringing accessibility to technology and information, all three simultaneously.
Absolutely. So we are going to try to a little bit disentangle that. And to the degree we can.
Something else which was crazy, they said if you don't adopt micro irrigation, you will not get elective connection.
That's in the dark zone areas. Yes, right. In the dark zone talukas that was done. I'm familiar, and I think most of the people who adopt in those areas, after they get the connection, they throw it away. So I'm not gonna show you here, but when you remove those areas, the results are unchanged. Now what the subsidy was, we know the number of subsidies offered in every particular sub-district taluka in a particular time, year and month, by a particular company. And we're just going to estimate basically a triple difference regression, which regresses either the number of the adoption or just the probability of having any adoption in that particular month in that particular taluka, regressed on an indicator of whether or not there is any additional subsidy offered in that particular time, location, and by that particular company. And then we are going to control for many characteristics, because this is a triple difference, we are going to be able to control for fixed effects for the combination of any location and company, company and time, and location and year. So we have basically triple difference is just like double difference. So in double difference, you have time and location, and you control for fixed effects for location and time. And here you have a variable that has 3 dimensions, and then you control for fixed effects for any combination of 2 of these variables. Okay, so basically what that does is it tells you that whatever effect you are seeing is only due to the combination of the 3 factors together. It doesn't have anything to do with the combination of the district and the company and the time, or the district and time by themselves. Okay, so that, it's not an RCT, it's not random, it's not an experimental result, but it eliminates a huge class of other possible confounders from the analysis. Okay, so in general, there are about 227 talukas in the state. 50 of them participate in these occasional extra subsidies. 11 out of 54 companies participate at some point in some of these special schemes. And about 54 out of 75 calendar months also are part of that, one of those extra schemes.
So are you saying the company makes a difference to adoption? That's the assumption here?
Yes, so the results will show that if a company in a particular area participates in some extra subsidy scheme, then only purchases by that company go up, and not by other companies, and not by that company in location or that location in time, but only when the 3 variables come together. Okay, so in these results, actually, so again, this is the probability increase of the chance that somebody in that taluka, in that time, by that company adopts. Actually, if you run without any controls, just a very simple regression, whenever there is another extra subsidy offered, the probability goes up by 30%. If you control for fixed effects for the taluka, the month, and the company separately without interacting them, so that's kind of like the difference in difference estimates, then that drops to 13% increase, but it's still there and significant. And in our preferred, most demanding specification, the triple difference, where you control for fixed effects for combination of year and supplier, year and district, and supplier and district, then it's about 9% increase in the probability of anybody adopting. Okay? So that's our main result. It's quite a large effect because it's almost like a doubling or even more of the baseline level of adoption. So it's a strong and significant result. We can do other things to check what's happening. For example, there are a bunch of different kinds of DRIP subsidies. Some of them are only offered to tribal population. Some are only offered to non-tribal population, and some are offered to anyone. We are looking at purchases only here by non-tribal population only. So when we separate into the 3 kinds of programs, we see the effect is coming only from those that are offered to either only non-tribals or non-tribals and tribals, which is exactly consistent. So that's also reassuring that subsidies that are being offered to only tribal populations do not have any effect on purchases by non-tribals. So it's like a placebo, which is reassuring. And the other kind of placebo we run is if we control for both the presence of additional subsidies for drip and for sprinkler, then only the ones for drip affect drip, and the ones for sprinkler do not affect drip. So that's also reassuring that what we're picking up here is not some artifact of the data.
Can you differentiate the adopters by complete adopters and partial adopters?
What does partial adopters mean?
The farmer has 10 acres, he puts smoothie on 4 acres.
Here we don't. We just look at whether adopting or not. But we could look at whether that is affected. So you're saying let's look at how much land is adopted as a function of this thing also. Yeah, I'm trying to remember if we have that data. I think we do.
You would have, once you have farmer's land holding and the area under drip or sprinkler or both, you'll be able to get that, whether they are complete adopters or partial.
I think we have that data, so I could look at that. Yeah, that's a good idea.
And extra subsidy is a dummy.
It's a dummy here, yeah. So we'll break it up a little bit later.
And also, I think there's a limit on how much you can do with subsidy in terms of acreage.
There is a limit,
Small
right?
farmers are not there. Essentially, I think it's 4 hectares is the maximum the subsidy you can do.
You're right, there is a limit. Yes, it's less than that even, I think, actually. You're right. Now you remind me. So in Andhra, for example, I don't think there's any limit. And here in Gujarat, it's limited to up to a certain amount. I think it's maybe even less than 4 hectares.
2 hectares maybe.
Yeah, yeah. This is basically the same thing, but we're limiting the sample to not really interesting. Here, the same thing, but we're running it as a Poisson regression, so it's not just a binary indicator of anybody adopted, the results are the same. Now let's look at a different aspect. Let's look at what type of farmers are adopting. So this is just in general from the whole sample, so I don't think you can see it. So, okay, so here, what you see is a distribution of the number of farmers according to what kind of the type of land holding, the category, between marginal, small, semi-medium, medium, and large. Okay, so those are the blue bars. Okay, so blue bars are just decreasing, the largest number are marginal, etc. If you look at the distribution of people who buy drip, of course, it's much more centered around semi-medium or medium farmers.
Did you control for access to groundwater?
Great question. So that's the next one. The next one is looking only at the distribution of landholding by those people who have a borewell. And the borewell owners are distributed also more skewed towards large, but I guess I would just focus on this part and see that amongst the drip owners, there's much more weight if you go to like semi-medium or small versus marginal, whereas the numbers go down even for borewell owners. So there's a disconnect there. Amongst the borewell owners, the smaller ones, even them do not take up drip.
No, small ones are doing quite good, no? Small farmers doing well on adoption. They're more adoption.
But in terms of the percent, they represent a smaller share in terms of owning drip than they do in terms of owning a well. That's the point I'm just making. Now, there's something interesting here, actually, in terms of a policy recommendation, which if you actually calculate how much a farmer pays per hectare to install drip, after subsidy and after all of these things, then actually the marginal farmers pay per hectare more than everybody else. So I think it's possible for 2 reasons. First of all, the drip becomes, there are some fixed costs in that. Like some of the units, like the filter and all that, it has a fixed cost. So if you spread it over a large area, the cost per hectare becomes smaller. There's economies of scale in installing drip on larger land. That's one issue.
It's not scale neutral technology, that's what you're saying.
It's not scale neutral, no. I think that's one factor, but on top of that, there is something else going on, which is that the way the policy is formulated, there is a limit on how much subsidy you can get per hectare. So the smallholders reach that limit and then have to pay more from their own pocket to make up for that. So the 50% thing is not the full rule calculation. It's not always 50% of the cost. There is a cap on the cost per hectare of the subsidy. And I think that actually ends up, I think there is a good reason to install a limit because you want to prevent the companies from trying to scheme and take advantage of the program. But it may have an unintended consequence of actually hurting the smallest farmers. So that's maybe one thing I would tell GGRC to be.
But then if it's limited to 4 hectares or 2 hectares, how does the large farmer achieve economies of scale? He uses the other without subsidy? He expands without subsidy contract later?
If he expands, but even if he installs it on just 2 hectares versus 1 hectare or 1 acre.
The other explanation could be that despite subsidy, the subsidized equipment is costlier than the market price of it. That's what we hear generally. Yeah.
That despite the subsidy.
You have very inflated subsidized prices of the equipment. even after paying 50% less.
Oh, so you're saying, so somebody who is a large farmer, half of his land is from the subsidized, half of the land from the
What you
market.
buy on the market is much cheaper.
But this data is from the, I don't have data on what they buy from the market. I only have data on what they buy from GGRC, and these prices are all based on what they pay by GGRC estimates.
No, but where do the economies come? It is not subsidized beyond 4 hectares or 2 hectares.
But I think even if you go from 1 acre to 2 acre, per acre, your price will go down. Because the fixed cost is quite substantial of the filters and the central unit of the system, so that plays a role as well. So if I show you this graph only for the actual cost, without accounting for subsidy, already then you will see a larger price for small area installation. And if you then take, and there's another effect coming from the way the subsidy is designed. So both are compounding.
Is it the amount spent by the holding of the farmer divided by holding of the...
Yes, it's per acre of what the farmer is buying from GGRC.
So the market farmer, because the denominator decreases, I think...
No, it's per hectare, it's standardized now, so it's not acreage, over total acreage.
It's not the total cost, but the cost per unit land installed. Installed. Not per unit land owned, but per unit land installed. So this is an issue. Now one would hope that maybe why are small farmers, so that is one explanation why small farmers use less. It may not be the only reason, but it suggests cost may be an issue. So maybe the subsidy can help small farmers more to start buying drip if cost is
But
the issue.
there are micro-irrigation guidelines which say that at least 25% of the adopters should be, or people covered under this scheme, should be marginal and small farmers.
Oh, I wasn't aware of that.
Guidelines of government of India, which every state has to implement.
But how can you implement, how do you?
To bring small farmers, they do that. I don't know how they show it,
Okay.
but many of them, they say that we are meeting that quota of 25%.
Okay.
Yeah.
Okay, I wasn't aware of that.
Yeah, it is there.
Okay.
A big set of deadline to how to implement this
I see.
in
So
a
what
critical
are the
manner.
cost components here?
Everything, the piping, the filters, the central unit.
Both the subsidy and the non-subsidy part of it.
This is only this is only what the farmer has to pay out of pocket here.
So if the farmer, let me assume if the farmer has borrowed,
Yeah.
so does that also include the interest cost?
Of the borewell? No, the borewell is separate. The borewell is constructed from the farmer's own.
This is only the equipment,
Only the equipment of the drip.
not the energy and equipment for
Right.
extraction of water,
Right.
only use of water. So this is after subsidy.
This is after subsidy. Yeah.
And on additional purchases of the same equipment, maintenance-wise, if you're replacing parts,
That I don't know anything about. I don't have data on that.
This is all based on GGRC data, right?
Yes.
It's not a primary survey.
It's not a survey.
because all those additional purchases wouldn't come under the subsidy anyway, they would have to be procured off the market,
So when I do the same graph for the total cost, not the farmer's own expense, it still looks like that the small farm, the marginal farmers pay more. But then there's another step. When you look at what the farmer is paying out of pocket, there's another jump. That's why I'm saying there are two things going on here. One is the economy of scale in the actual cost, and then one is the subsidy, the way it's designed.
Does this include the maintenance cost? No. It's only
No.
installation cost.
Yeah, it's the initial cost only.
Yeah, initial cost.
Initial cost,
But
yeah.
is this one-time subsidy?
It's one time.
One time,
Instead
yeah.
of
I think in Maharashtra they are like, you can have it after 10 years.
Yeah, that is fine, but I don't think anybody has gone through that cycle here.
Yeah, oh, here whether they can, yeah, I don't know what the time limit is here.
Maybe about 10 years, 8 or 10 years, yeah. On the same piece of land, if you want to redo it,
I see.
then there's some limit. You can't do
Yes, there's some limit. And here, yeah, I doubt many people have already gone through that here. Yeah. So the idea was, okay, so we saw that when there's extra subsidy being offered, more farmers are taking up. But the question is whether that also helps more smaller farmers to kind of join this, adventure, right? That would be the hope of what subsidy would do. It's supposed usually the hope is that it helps smaller farmers. But so when we look at the effect of extra subsidy, first of all, the first column is you see how much of the, what is the share of the cost that is subsidized. So this is just, so this is from taking, remember we are defining the extra subsidy program based on information on when those subsidies were happening, okay? This is data that is unrelated. It's from the records of all the purchases of DRIP in a GGRC database. So this is just confirming that these are accurate, because when you look at the share of the cost that is subsidized, it is higher in those places and companies and times when the subsidy is supposed to be higher. So it's just a check on what is exactly you expect to happen, right? Farmers are paying, the subsidy is a larger share whenever there's an extra subsidy offered. So it's just a check that we are consistent. Then if we look at how much land is actually installed with DRIP, which actually that is going back to your question before, we don't see an effect. So it seems to be that the extra subsidy is operating in the extensive margin, meaning more farmers are taking it up, but they're not installing more than usual just because the subsidy is higher. So if the average is 1.6 acres, it doesn't go up by anything substantial. We don't see any effect on how much land they are installing with.
There is kind of ceiling for each farmer which operates, right?
And either it's the ceiling that you mentioned before, or maybe it's a psychological ceiling or something. And what we had hoped was that the land holding size, not how much land is installed with DRIP, if smaller farmers are entering when there is a small subsidy, we would expect to have a negative impact here. But we're not seeing anything big or robust. So we're seeing negative coefficients here, but they're imprecise and not that big either. So that's maybe the disappointing thing about the subsidy. It's helping people, but it's helping people who are a little bit better off to begin with.
Is there another reason of the risk-averse behavior of the smaller farmers? Risk-averse behavior is the marginal farmer tend to grow the crops just for eating, for the family, for own consumption. There is no, even if it is ready to land, it doesn't matter. Why to invest more for growing the same thing and making by itself?
I think it might be, but you would still hope that giving more subsidy would make the farmer feel that they are taking less risk, right?
Yeah, but I mean, maybe because say if a farmer is flooding, maybe according to him, the flooding, maybe using of the flooding is one way to grow the X amount of the crop. If you reduce the water, there is a risk to it that you may end up with a lesser amount of crop in the end of the day.
You mean a perceived risk in the mind of the farmer? Yeah.
There was a demonstration of it that the lesser amount of water will lead to the same amount of crop.
Sure.
In the end of the day, because we need to consume it at the end of the day.
Right. So the farmer may feel that it's unfamiliar and risky. Anything new is risky, right? And you're saying maybe small farmers are feeling more risk averse than bigger farmers.
So even after subsidy is about 40,000 rupees per hectare.
It's not cheap.
A small cost.
Right. So I think that may very well be one of the factors, but you would still hope. That's part of the reason that you subsidize, maybe when you give extra subsidy, that reduces that perceived risk because I have to pay less for it. And we don't find evidence for that. Now, there might be other ways to deal with risk, like, I don't know, some guarantee or something, but I don't think anybody has tried to do that.
I mean, few things that many NGOs does is the demonstration crop. Say, I mean, you are using a particular village, installing a, say, sample drip irrigation for some time. One particular field of the same size in the same village, demonstrate, look, in the same season you grow the same amount of crop, same amount of crop.
Did you check for cropping pattern across farmer categories?
Whether different crops are...
Some are more amenable to this than others.
So I know what is the distribution of crop types across all the adapters. I haven't checked whether extra subsidy moves that distribution, and I could check it, but I haven't yet. But I just want to, on your comment, GGRC, as far as I know, does not engage in demonstration. They just administer the subsidy. Now, you might think that it might be worth trying to do something like that, perhaps. It may be done by private companies, but we have results also, I don't know if I'll have time to show you, that farmers really learn from one another. So once one village adopts, nearby villages are more likely to adopt in the following year. So so we have to finish in 2-3 minutes, basically? 5-10 minutes, okay. So, okay, now, Anish made the point before that maybe the effect of the extra subsidy is not because of the cost. Maybe it's because this NGO that is a partner or whoever is a partner of this thing is going around also making farmers more aware of it. So we can't really rule that out completely. But if we separate those extra subsidies into two groups, groups that partner with local NGOs and those who do not, we don't find any difference in the effects. So that's one thing. The other thing is we can estimate the effect of every one of those 50-something extra subsidy programs separately. So what you see here is for every point here is one extra subsidy program, and the y-axis is the impact that that particular program has by itself. Okay, so these are the impacts of the various subsidies, and here we plot them against how much extra percent that subsidy is given. So you see that programs that offer a larger increase in the subsidy in general seem to have a larger impact on adoption.
After state doesn't matter, right? After about
maybe, yeah. So there's not enough data here to estimate like saturation, but there's a very significant positive slope here. So that's all I can say with this data. I don't have enough. If we had hundreds of different subsidy programs, maybe we'll be able to say that. So that's as far as we can try to separate the effect of the cost increase and other things. But it's a concern. Okay, I'm going to skip this. We do a similar exercise for the effect of tribal subsidies on tribals, and we also find that they also have a positive effect by looking near the borders or tribal talukas. I'm going to skip that for lack of time. And then I want to say a couple of words on this question of whether adoption of drip actually saves water. So, you know, it's actually the promise to save more water is based on usually agronomists just saying, look, you need half as much water to grow your banana crop, so farmers will save half of their water. But these estimates don't take into account behavioral responses, right? There are so many things that can happen. Think about a farmer that is not exposed to an incentive, that is not paying for the water. Once I install drip, either I can use half the amount of water to cultivate the same area, or I can use the same amount of water I used before to cultivate twice as much area, right? For example, if I have enough area to expand to. So what would you do if you don't have to pay for the water? I think I'm more likely to use the same amount of water to cultivate more area. And that's great for the farmer's income, but if the government is concerned about stopping the water table decline, it's not necessarily going to help.
but it's more productive use of water, right?
It's more productive use of water. So more production, but which is great. So I'm not discounting that at all. But part of the public interest in promoting a resource-saving technology is to conserve the common, the public good of the water resource, the common property resource. So it's just good to know whether that is something that is happening or not. This is similar to what we sometimes call the energy use paradox, where you give people more efficient appliances and they actually end up using more, or you give somebody more efficient cars and then they drive more. And another factor here is just similar to that, that if you suddenly you're making more productive use of water. So per drop of water, suddenly instead of making 5 rupees, you are making 10 rupees. So if I am now able to use water more productively, will I not want to use more water for the same money? Either I use the same amount of water, or maybe even I drill another borewell or deepen my borewell to get more water out, because suddenly I get more rupees from every liter of water that I extract. So because of these reasons, it's not obvious, and in fact, it may be unlikely that adoption of technology results in using more water. So this is one simple paper where we just did a simulation across all of India. What would happen if everybody in India adopted drip irrigation in the crops that can support it? what would happen in the groundwater situation? So this is the present situation right now. Right now, there are 232 cubic kilometers of groundwater that are excessively withdrawn in the sense that they exceed the natural level of recharge, and that's what's causing water tables to decline. And there are 108 over-extracted districts in the country. If you do a simulation assuming everybody takes up drip irrigation and behaves like the agronomists say, and just use less water according to what drip allows you, then indeed you reduce a lot. So now you're only over-extracting 160 kilometers, and the number of over-extracted districts goes down to 63. This is excessive construction out of the total so this is basically 60 out of 232. Sorry, so I was wrong. 232 is the total amount of groundwater extracted, out of which 60 cubic kilometers are excessive, beyond natural recharge. Okay? That goes down to 20 if everybody adopts drip irrigation. But if you take into account how much areas are not cultivated at the moment, or especially in the Rabi season or in the summer, and then you let people expand the area first, and only once they saturate the area do they stop using water, then much of the benefit of drip goes away in terms of reducing excessive use of water. So this is just a simple calculation to show you that whether people use the same amount of water to grow to cultivate double more area, so whether people use less water or expand the area first makes a big difference on the country level picture for what will happen to the water. Okay, so it's just showing that the question of what people actually do after they adopt drip, do they use less water or do they expand the area, is important. It makes a big difference.
This is assuming 100% adoption.
Yes, as a mental exercise. All the potential, just as a mental exercise. Now, what do people actually do in the data? So to answer this question, we worked really hard to locate for about 4,000 of the drip adapters in the GGRC data set. We were able to find them in the records of the utility company and then extract from them the billing records. Now, this is only valid for those consumers, agricultural electricity consumers, who are metered. Most people are charged on a flat basis, but there are some who are metered. So this is only restricted to those type of consumers. So for these guys, we know when they adopted the drip, and we also know the history of how much electricity they use for pumping. So that was a very intensive data gathering exercise. Don't ask what we went through. But eventually, we were able to do it for 4,000 of these guys. And I'll jump quickly to, we also did a survey to ask what people do, but if I'll just jump quickly to the results. So in this graph, the year 0 is the year in which they adopt drip, and we estimate how much they use before and after compared to the year 0. So you see, before the year 0, there's no difference. But in year 1, there's an increase of 5%, an increase, not a decrease, in the amount of electricity they use for pumping groundwater. So it works in a counterintuitive direction, which is what other studies have found. But if we stopped here, that would be the end of the end conclusion. We can look at further years down the line, and after 3 or 4 years, something changes. And suddenly we see a drop. What is going on here? I'm not entirely sure, and this is still something we're still analyzing, so this is rather early. But people from drip companies have told me that in their experience, when farmers first take drip, they treat it just like a conveyance device. It's like a pipe that moves water to the plant. They don't believe that they can reduce the amount of water. So they let much more water flow through these pipes than what is recommended because they don't believe that just a few drops of water will make their crop grow. And it takes them a lot of time to develop confidence in the ability of the drip to actually make the crop grow with much less water, as the agronomists at the company experts recommend. So that could be one explanation for why it takes time for the negative effect to overcome the positive effect. but we don't know at present how likely that explanation is. I think we might need another project with some more intensive field work to accompany new adopters and see that, which something maybe we hope to do at some point. So maybe there are various things going on. Maybe there's area expansion going on one hand. Maybe even area expansion should not result in any hike. It should remain the same amount of water is used constantly, because area expansion just means I use water more efficiently, but I use the same amount of water. I still turn my pump on for 8 hours a day, and get as much water as I can. But an increase could be an artifact of, wow, water is now more.
Let's say 2 crops instead of 1, then you end up using more energy to really get the second crop.
That's exactly, right. So that could be that positive impact. On the other hand, maybe when you start to fully utilize the effect of the drip to reduce water consumption by half, that maybe can overcome that effect. So maybe once people use it really efficiently, they start to overcome the effect of using more area, which, after a while is saturated. There is only that much area that you have. So I don't know. This is just speculative at this time. This is what regressions are saying. See, this is nowhere near 50% is what agronomists are saying. It's still, but it's at least negative. So this is just possible speculation on what's going on.
There could be an impact of rainfall also. If these were years when the rainfall was actually good.
But keep in mind, these are not calendar years. So this is normalized the time of adoption. The time of adoption actually varies across our sample. So we control for all the things that happen by calendar year in this regression. We control for many, many year fixed effects, year district fixed effects, and all of this. That's it. I'll just end here. I won't show you the results about how farmers learn from one another now because we're out of time. But basically, that suggests subsidy seems important. That means in that sense, subsidies seem to be working. But the full assessment of whether subsidies are justified from a social cost-benefit analysis will require a lot more work. We need to figure how much water it saves. We need to figure whether it helps other people learn from those who are adapting subsidized adoption and so forth. So this is just the beginning and I don't know how much further we can take it, but I'm very eager to get any ideas on what other analysis we might be able to do with this. Thank you very much.
You've done the analysis on how people are using the drip for the cash crop or the food crops. Say if there is lesser adoption or more adoption for the ones who are growing food crops.
But drip is hardly used for food crops, so it's not suitable for wheat, for example. It's all for cash crops. It's all for horticulture and cash crops.
There is this issue of tubal companies in Gujarat.
Yes.
Come together. How did you tackle that? When you said tubal owners,
Right.
individual owners.
Right.
How do you allocate or link it to the area adopted under?
When I show the distribution of borewell owners, you mean? So I just use data from like the minor irrigation census that tells you of the borewells, how many of the owners are in different categories. And I think you miss. I don't think, yeah, so the minor irrigation census is not very good at capturing those. Now I'm familiar with that phenomena, very fascinating thing. Amazing how complex those structures are. It's like, these guys are just brilliant. When it comes to extracting water, these guys are just amazingly innovative. When it comes to conserving water, a little bit less so. But really, I spent like 2 years in the field, coming and going to this project, and I still don't understand exactly they have such complex ways of arranging the water sharing. It's so sophisticated. But I think that is also a barrier to adoption, by the way, of drip. They told me that repeatedly because it requires coordination. The way that they share the water in these tubewell companies, you can't just have one person adopt because you get the rotation every 2 weeks, you get the water. Drip doesn't work like that. Every day you have to give it like half an hour. So everybody has to agree and they have to change the whole coordination. It's hard to get 10 people to agree on the scheduling.
I have this question, like besides extraction of water, groundwater, government of Gujarat is also promoting surface water through canal, the Narmada Canal, and other than that, there is water water theft from the Gujarat statewide water grid, which is meant only for drinking, but the farmers are taking for irrigation.
I see.
So in such a situation where there is such high competition, and of course there is no tax for water. Like, how will drip be adopted if it is sustainable and it is more good from point of view of the environment, but if there are such things happening and if the government is not doing anything and it's promoting surface water so much, so you think the drip irrigation will be adopted in Gujarat more?
I mean, the trends are showing more and more adoption. I don't know when it will level off. The surface water thing, yeah, I mean, the government is providing more surface irrigation. I think farmers are probably less likely to adopt drip if they don't feel any scarcity at all. But that's also a research question, actually. You know, it will be interesting to see that. I don't know where to get information on where the canals are exactly. Actually, I'm having a very hard time finding that information, and I really need it for some other project. Where canals are arriving and so forth, which areas are covered by canals. It would be an interesting study to see how that affects also the take-up of drip, actually. That would be very interesting. So it could be a great PhD thesis.
I think I could take that up and continue with And another question is, Kheralu district, you'd be knowing of Mehsana. They have installed a lot of drip irrigation. Some of the villages have something like 70 to 80%
in Mehsana?
In Mehsana, the Kheralu district.
Kheralu Taluka.
Yeah,
okay.
Kheralu Taluka. Yet the water tables have not improved. So is it because you think the drip, they are using the same water to irrigate more, or it could also be because of some other factors?
I think that's a great question. So that could be one reason, that they're not reducing total water use is one possibility. And another one is just, you know, even though a lot of people adopted drip, there's still not a large fraction of all the farmers. So to detect that effect on the water table may be premature. Maybe you need like a much more...
Also, the partial complete. Each farmer is also not fully complete. Part of his farm is drip, part is...
Exactly. So not even the whole land of every farm.
Complete adopters, yeah.
So it's probably too, I mean, that kind of diffusion is probably not enough to reverse the water table situation.
But there is this another phenomenon, which is that when we are talking about other incentives other than subsidy, in Mehsana and Banaskantha, there are cases of farmers adopting it without the subsidy even.
Yeah, Banaskantha is, I guess, the most.
Necking coming in to do potato contract farming. So they said we will not take any farmer who doesn't have water-saving technology down there.
Right.
So farmers paid from their pockets to become contract growers.
I see.
So there are other ways of channelizing it.
Yeah, I would love to have data on non-subsidized purchases of drip, but those...
That will not be easy.
No, that would be... You have to make friends with the company, very good friends. Even they may not know, I don't know, but yeah. So.
No, we will have find many in the field survey. If you go to village, people will have they done without subsidies.
Yeah, you could do a big survey. Yeah.
But other argument against subsidy that this is not working because it's a product subsidy.
Because of?
It's a product subsidy. You subsidize the equipment.
Right.
And somebody argued that we should subsidize creation of a market for it, not the final product delivery. But anybody is investing in making farmers aware and convinced to go for this kind of technology. NGOs and others, they should be rewarded, not companies.
But how do you that's interesting, but how do you measure in how successful an NGO was in...
They will bring the farmers who have intention to come and register with you and to give them the...
I mean, that's an interesting approach.
Yeah, that's what they're saying, that perhaps that is a better way of channelizing subsidies for more effective.
Would be interesting, yeah.
So that combines all three channels, you know, information, and subsidy.
Except for the cost, right?
So that people invest in market creation. Right now they are not investing in creation, they are just investing in already created market by subsidies. The company is just eating the cream.
Yeah, so that's an interesting approach. I don't know how that would be implemented in practice. I think it's a bit, the devil is in the details, I think, but it would be interesting to see how something like that could work, yeah. yeah, this is a lot of money, right? This subsidy program.
Yeah. More questions? Yeah. So thank you so much, Professor Fishman. Yeah. He's available here for a few more minutes in case some of you want to interact with him. Thank you so much.
See you in Tel Aviv in July. Okay?
So some of this work is published?
Some of it, yeah.
Okay.
And some is just shamelessly delayed.